All right, we are back with part 4 of the Extra Math 3. These are the math problems from the HubSpot here. Really good practice test. This, one of my favorites. There are so many good problems we've covered, and there's so many good problems we're about to cover. So starting with number 23 here. Again, I'll say this over and over. It's inclinations, right? Immediately when I see this, I see A and B, and I consider, could they be complementary? That should always be one of the first things you consider when you see these kind of two angle problems. And I think it's reinforced when I see this, sine of A equals cosine of B. Real quick, the fast test we can always do is I make my 3, 4, 5. And I can put B up here. Let's get a different color. And I just do, okay, sine of A is equal to opposite over hypotenuse, so 4/5. And I say cosine of B is equal to adjacent over hypotenuse, which is 4/5. And we prove it real quick, but this is always something to consider for these two angle problems. I know that sine of A is equal to cosine of B. I know they're complementary, and I know that complementary angles are always going to add up to 90, right? We have a 90-degree angle here, which means to get to 180, A and B have to be 90 together. I see this equation for A is equal to and B is equal to, what they want you to get towards here is that these are going to add up to 90. So if I just make my equation, 4K minus 22 plus 6K minus 13, this should get me to 90 because that's just A, that's B, and they should combine to be 90. And I just add these together real quick. I get 10K minus 35 is equal to 90. And then the final line here should be 10K equals, I think that's 125. Divide by 10. And I should get 12.5. We just move a decimal point. So these are always awesome problems. With enough practice, these should be freebies for you. Yeah, it's nice to see, again, if you go through my other worksheets, you'll see this problem conveyed in like 5 different ways. Sometimes it's a word problem. Sometimes it's kind of picturesque like this. Really good problem. And another awesome problem, let me get rid of this little bit at the top, is this these types of questions. Let's see what they want. So we have Cole, who has this beaker with n milliliters that he's going to distribute to students in his chemistry class. If he gives each student 3 milliliters of a solution, he will have 5 left over. So this should make you think of something. If you want to pause it, if you want to try to derive whatever they're asking, let's go into it, right? Each student, an unknown variable, gets 3, and then he'll have a constant 5 left over. We should always be considering y equals mx plus b too, not just the complementary angles, but y equals mx plus b. So if we start with an amount of milliliters, right, and we give 3 to each student, and we have 5 left over, right? This is going to be a really important part of this test, is being able to make these equations. And let's try to use the second equation to help infer how we made these, right? The second equation looks like, in order to give each student 4, so already I'm going to go ahead and write down, actually, I might have to shift it a little bit, but I'm going to go ahead and write down 4x. He will need an additional 21. So let's write it down and then let's talk about it. So he needs an additional 21 to be able to give each student 4. So in the first equation, he already has this beaker with milliliters in it. He's able to give each student 3, and then he has 5 left over, right? For this new kind of distribution, he needs an additional 21 with the beaker that he already has to get each student 4. Doesn't say anything about about milliliters being left over. So these are the two equations we derive. I can just throw them both in Desmos, and it should give me my intersection point should be my solution. It looks like they want us to solve for students. So remember, this would be the milliliters they start with. These would be the students. So we're solving for x. I'll just do quick elimination. I think if I just multiply this by a negative, and then I can, kind of add them together. My y's should cancel out. I should get 21 on the left side. On the right side, I should have an x left over, and then if I distribute the negative, I should get -5. X looks like it's going to be equal to 26 here, or 26 students. So not too bad of a problem. I actually think it's really good practice. These can be some of the harder types of problems where we can't just use Desmos to solve everything. We need to derive the equations. And what better place than practicing than this problem? Awesome one. And let's jump down to 26 here. Right there. Let me shift this over. Okay. So let's see what we have here. I already see 2 points with a K. So I'm already thinking like this is going to be maybe like derive a slope from it. We have 2 points on a line that also passes through the origin. So technically we have 3 points. Should be more than enough to get us a line here. Which of the following could be the value of K? So yeah, what if we just do, I'll start at one end and I'll say from 2K to 0, 0, right? That should be able to get us a slope. Remember that this is my X, this is my Y, and I want to do change in Y over change in X. So my change in Y is going to be K minus 0. And then my change in X is going to be 2 minus 0. So this is K over 2. And remember, all three of these points are on my line, so all my slopes should be equal to each other. I'm going to set this equal to my other slope here. Let's do maybe, so X, Y. We could do 32 minus 0. And I could do K minus 0. So all I did is I took the 2 points they gave me, and I'm just finding slope of both of them, right? So I found the slope between 2K and 0, 0 and K32 and 0, 0. And I'm saying that both of these slopes should be equal because all three of these points are on the same line. So they should all have the same slope between them. So this is going to be equal to 32 over K. And I'm going to cross multiply these, right? Because those two slopes should be equal to each other. And I get, it looks like 64 is equal to K squared. And you could have accidentally got a negative here. If I would have done, maybe I said 0, 0 was between them. So maybe I did 2K to 0, 0 and then 0, 0 to K32. If you end up with like a negative 64 here, it's not a big deal because we don't necessarily know which point is in which order, but we're not going to be able to take the square root of a negative. So even if you do get a negative here, it's fine. Just get rid of that. Your K, I think, should end up equaling 8 here. Square root of both sides, 8. And let's make sure C for 26 is correct. Yeah. So again, really cool problem. Deriving our slope, just knowing that one of our K points to 0, 0, another one of our K points to 0, 0, we should get the same slope. Not too bad. And number 27 here. Oh, there are so many good problems on this test. This one, I think, is really good. So let's see what's going on here. So we have a rectangle, and it's being altered. So already I'm going to draw my rectangle because I need to know my original compared to the altered version, right? Let's give it XY. I pretty much always just use XY. So we'll give X for, length and then Y for the height, kind of. So XY. So my area of this would be XY, or maybe they'll give us like an amount or a percentage. So before I write that, let's see. Let's also draw our second rectangle they want here. And increasing its length by 10%. Okay. So we already said the X is going to be the length. So increasing it by 10%. Remember, for percentages, we always start at 1. And if we increase, we're adding that percentage. And if we decrease, we're subtracting that percentage. So if they're adding or increasing 10%, this becomes 1.1 X. And decreasing its width by P%. Okay, so we could do... Now that's where it gets tricky, because are we going to use P as a decimal or are we going to use P as a percentage? So let's try to cover all our bases here. So let's say P is 10%. Because look, they do want our answer in percentage. You can see there's no decimals. These are all whole numbers or integers. So if P was 10%, we would want 0.9y. So what if we did, yeah, you can see down here. Let's do like 100 minus P divided by 100. And then that would be multiplied by y. Because look, if I plug in 10 for P, we get 90 over 100, which becomes 0.9y. Does that make sense? So that should cover all my bases. That should make this problem nice and fluid, and I'm not gonna mess up at any point. So let's try to write that up above. So, and then I'll be able to solve down below off space. So 100 minus P over 100, and then multiply that by y. Perfect. Let's get rid of this because I'm gonna have to solve. And what do they tell me next? I think we need one more piece of information. These alterations they've done decrease the area by 12%. Okay, so this 1xy has now become 0.88 xy, right? So a 12% decrease. So if it used to be, you know, area equals 1, it is now area equals 0.88, or you could say area used to equal 100, now it's 88, right? So let's try to see what happens here. So we should be able to, and here's another, you know, kind of skill to practice. Whenever you have a quantity in written two different ways, what quantity do we have here? We have the area of our altered our altered rectangle. One of them is 0.88 xy. This would be 1. My second area of my altered rectangle would be these multiplied together. So if I multiply those, couldn't I set it equal to 0.88 xy? Right? So let's try that. Oh, this one looks like it might be brutal. So we have, where can I write down here? I can. Actually, we can make this even higher like that. Okay, perfect. So I'll do 1.1 xy times 100p or minus p divided by 100, and then this is going to be equal to 0.88 xy. So remember, whenever you because I've seen this in a lot of these kind of harder types of problems, whenever you're able to get a quantity written two different ways, you can set those quantities equal to each other. So these both represent the area of my altered rectangle. So I can divide both sides by 1.1 xy, right? Divide by that, divide by 1.1 xy. That's going to go away. My xy should go away here. And let's do this real quick. So 0.88 divided by 1.1. Nice, easy number. We get 0.8. Let's get a different color here. So we should get 100 minus p over 100. And I'll scroll down a tiny bit so you can see that. Is equal to 0.8. And just multiply both sides by 100. And now I can write up above because there's very little left. Multiply both sides by 100. I get 100 minus p is equal to 880. So it looks like p should be 20. C for this one, C for 27. Let's make sure it's right. That is correct. So, I mean, this is like back to back to back. These are excellent problems. They're so good. I almost want to pause it here because you kind of just need time to absorb. I would practice these 1, 2, 3, 4 times because these are going to be some of the most complex problems they can throw at you. And if you can solve these, they're not going to be able to surprise you. So I will pause it here. That means I'm going to have to come up with like part 5, part 6, because again, there's so many good problems here. 34 is awesome. 35 is awesome. Very good problems here. Make sure to jump in for the next part.